Good morning. Hope everybody's having a good day today so far, but I heard that maybe that's not the case for everyone. If we get to note card 31, curve sketching, and for this we have another diagram, and so I want you to write this somewhere on your paper. And before I'm going to erase what I have here and do a reconstruction thereof. Okay, what I want you to do is somewhere below here to draw a circle.
Draw like a, do you want us to try?
Yeah, so to draw some kind of a circle that is cordoned off into 4 sections by an XY coordinate plane. And what we're going to do with this circle diagram is get the components that are going to help us sketch the curves based on what we've done already. And right here in the upper left, what we're going to have is I want you to write a plus, and immediately below that plus I want you to put a minus. And then if you can figure out what that's about, let me know. On the upper right, we're going to put a minus, and immediately below that a minus.
I don't know what this means.
Okay. Now on this lower left, we're going to put a minus, and immediately underneath that a plus. And then the lower right, we're going to write a plus plus.
Ah.
So you got that pattern. So there's some kind of a pattern if you think about it. Okay, now what does the sketch of those pieces of the circle and the pluses and minus signify for anything you can think of, curve sketching or anything?
I have no idea.
I don't get the question, I don't think.
Okay, what this is, I'm going to write next to it this. I'm going to write F prime, F double prime right here, and here we're going to put plus minus, increasing, decreasing, concave up, concave down, and immediately below that on the F1 row, plus minus, increasing, decreasing, and then right below that, plus minus. Okay, now what do you see?
I see this thing.
Oh, okay.
We're on that same page.
On the same page, all right.
Yeah, because there's space.
Oh, okay, yeah, so that's right. So, yeah, so that's a good idea. Well, Kylie put it right next to her one that has the chart on it, which is this one right.
I'm gonna do that now. How'd you draw your circles so good?
I traced my poster.
Cheater.
You wanted it?
Where was that?
I was like, oh my god, did you freehand that?
Didn't trace it.
It's on the wrist.
I have it the other direction.
It is.
That doesn't look like a circle to me, Kevin.
Yeah, so right here is where you put it, next to
Yeah,
this one.
okay.
Yeah. And we haven't got to this row of the integral, the antiderivative of f,
That's a pretty good one.
but eventually that's coming. Yeah. Okay, let me show you what these are. Okay, the curve that is shaped like this has the first derivative that's positive, which means increasing, and the second derivative, which is negative, which is
C.
No, it's concave down.
concave down, see? So this one here tells you F is increasing, or if this is positive, okay, this first one here on top, that tells you that F is increasing, and the next sign right below that tells you if that's going to be concave up or concave down. And so the piece is going to be shaped that is where F prime is positive, the function is increasing and is concave down, is going to be shaped like this. So what this circle represents each quarter a generalized shape of the curve that's going to result from this combination of signs. And we're going to see this in a second when we have those number lines stacked upon one another. And we're going to be able to, based on those number lines, do what with those number lines? Sketch the curve that the function produces. All right?
Interesting.
Yeah, so it's interesting. And you got to consider going left to right. But to me, when you have these two drawings juxtaposed next to each other like that, and you bring the number lines into it, what it is you're able to, at least for me, dimensionalize your understanding and figure out what's going on with the different dimensions of the functions doing that. And that's what we're trying to get to, that level of understanding. And the other day in class, we worked out this thing right here. And I think this is probably a good candidate to look at what the sketch of a function looks like. Now, what happens is that oftentimes when you're asked to draw a sketch of the function, they might give you a starting point. Okay, they'll give you a starting point. They'll say f of 0 equals, in this case, that's going to be negative 64 or something like that, right? F of 0 is isn't that right? Because that's going to be negative 64, isn't it? Anyway, so they would say f of 0 is negative 64, and so what happens is, and how do I know f of 0 is negative 64?
Because you put it into...
Yeah, because if I plug in 0, I know I'm going to have negative 4 cubed, right? So f of 0 is negative 64, so I know this could be a starting point.
Oh,
Now,
wait.
you see that?
And it also multiplied by 0?
Actually, that's going to be 0 at that point. You're right. No, this is going to be 0 here. I was thinking if we didn't have that. So it's not. It's actually going to be 0. So let's go ahead and do that. So Aaron's right about that.
I was so confused.
No, let's go ahead to 0. Okay, so we're going to have 0, 0 as our starting point on this. And it's easy to lose sort of how much you are, but anyway, what you look for is you look for your number line, and so you see a number line here, and what's the first interval we see here?
1.
Okay, we see from negative infinity up to 1. And what do we have between negative infinity and 1? What do we have on top of each other?
Minus positive.
We have minus positive.
Or negative positive.
So what does negative positive look like?
Oh,
It's going to be the lower left part of the circle, right? So that means all the way to 1, we're going to have a piece, I'm going to draw this in blue, that looks like this, all the way, so that's the shape of the curve to that point. Does that make sense? Okay. Now what's the next interval where we see the number lines stacked upon each other?
positive?
1, 2.
Yeah, from 1 to 2, we have a
On,
plus divided under, and a plus underneath. So what does plus plus look like?
The bottom right.
The bottom right. So all the way up to 2, we're going to look, it's going to look like this. Okay? Now at 2, what happens?
it goes,
Okay, we have a plus over a minus,
Positive, negative.
so positive negative is going to look something like
top left.
this. Does that look right?
Yes.
All the way up to,
Quattro.
all the way up to 4. So this will be like all the way up to 4. And then from 4 on, what do we have? Plus plus, which is going to be like this. Okay?
Well, that's a whole graph.
Yeah, it's a whole graph. And what I want you to do for corroboration's sake, and I'm not sure about the amplitude. I'm not sure about the proportionality. I think this happens to be right at 4. I think this happens to be generally right. But what I want you to do is take this in your calculator and just kind of see what it looks like in your calculator. And see if this is more or less what it looks like. And of course, the details of it with this, you're not looking for details perfect in curve sketching, but you're looking for, and so you're not looking for perfect proportionality, but you're looking for those curves, characteristics like that coming up.
Oh, except my window's a tad off.
Yeah, the window for these most of the time is going to have to be adjusted.
Yeah, it looks right. Super.
Let me go ahead and put it for the viewers here. So we get, I'm going to put x times quantity, is it x minus 4 cubed?
Yes.
So I'm going to go to zoom standard first. So we can't see it really well, but if we go to like, I guess the window of, I'm going to go to like -2 to 8.
Yeah, he's about 40.
I want to put 8, not 80. 8 here, that's good. Minimum, was it -100, something like that? And we'll just leave it like the scale, put it 10. Should be able to see something here. Yeah, actually but you can see the general shape is right, isn't it? We have that thing, and then right here, where's our point of inflection occur on this?
1.
At x equals 2.
No.
Okay, so we go from concave up to concave down at x equals 2, and then we see the function increasing, and we see a second point of inflection, don't we?
Yes.
At 4. And so, to me, to be able to do this from this data, to me that's pretty neat to be able to do that. So, what I want you to do is this. Let the graph show number 2. That's one direction. Okay, what I want you to do is take this thing right here and just try to, and I can help you with this, so I want you to kind of work this out, and part of this is what we were working on with that quiz I gave you recently. Carson has this in hand. Is sort of the next step is putting this together using making the sketch of that. So go ahead and work on that for a little bit. You have to find the first derivative and the and the second derivative, and find the critical numbers and all that kind of stuff.
Mr. G?
Yes?
Well, let's connect the quizzes.
Yeah, and I'll tell you something about the quizzes. I'll do that, and there's actually a video one. At the end of class, I'm going to give those to you.
Okay.
And there's another thing I want to do. I want you to correct the quizzes, but I want you to watch the video on doing it.
How many of them do you have still?
Pardon me?
Have you had any of them back?
I haven't had any of them back. So I want you to do that, and then I'm going to give you another quiz after that that's similar to that. So just sort of the reinforcement of that.
All right.
Another quiz that's due today? Or-
No, probably maybe tomorrow. Maybe that'd be a good assignment over the break. That's a pretty short assignment for the break. I don't have a big packet set up.
Aaron's gonna be disappointed.
No, Aaron will be fine. He'll be out making sausage with his dad or something.
No, this is all me. My dad's at the duty.
Oh, so you're gonna do it yourself?
Yeah,
What are you making?
I ain't telling you.
And this
Mystery meeting.
Carson,
Wow.
director, find yourself.
Guess which one is you? See if you can guess who everybody is. See if you can guess who everybody is, starting from the top.
Okay, Aaron, Gavin, me, and Gavin.
Yeah, he got it. Yeah, I told you he did.
I'm pretty good though. I
Why can't you
can't.
get smiley face?
I don't know.
That is good.
Whenever you walk in class, when you start.
All right, so you guys are working on this, right?
Yes, I found the critical numbers.
Oh, you did, okay. Let's just go. What I want to do is I'll just go over this pretty quickly here. So, what we have here is f prime of x is equal to 3. We have x squared minus 1 squared times 2x. So that's going to be 6x times x squared minus 1 squared. Okay, so do you have that?
Yes.
And so our critical numbers here are going to be what are your critical numbers going to be?
They're gonna be 0, -1, and 1.
Okay, how'd you get -1 and 1 here, Aaron?
Yeah.
Because it's the old difference of squares.
Yeah, so we can rewrite this x squared minus 1 as a difference of squares. And so it's kind of like, and it's not readily apparent, so I'm glad Aaron caught it. But it's like this x squared minus 1 is going to be like x minus 1, x plus 1. And then you square all that is what that ends up being. Okay? But this is true also. But there's your critical numbers. And so now can you tell what values of f is increasing?
Yes.
So -1, 0, and 1. And so you can take this thing right here, but you know all this is squared, right? So this is always going to be what?
Positive.
It's always going to be positive here, and this one here is going to be positive or negative. And so we have here is we have f prime, and right below it f. And so if we're to the left of -1, what is that going to be? That's going to be a negative times a positive, so that's going to be negative. So we're going down here. And then between -1 and 0, we have also negative, right? Because we're still going to have negative times positive. And now to the right of 0, we're going to have positive, positive. And then also we have positive, positive. And so now we can see where the values of x, where is x increasing? How would you say that? F is increasing.
If it's increasing, would you just do from 0 to infinity?
Yeah, so Kylie came up with this yesterday. Was it yesterday we talked about that?
Or the day before yesterday.
Or the day before yesterday, yeah, day before yesterday. Is really, truly, you can make this from 0 to infinity, or you can write it with a break at x equals 1, either way. And there are pros and cons to either version thereof. Okay, and this says find the x and y coordinate of relative max and relative minimum. Do you have a relative maximum here?
No.
So there's no relative maximum. Where do we see the relative minimum?
0.
At 0. So if we plug in 0 for x,
It's -1, man.
yeah, we're going to have -1 cubed, or -1. So we have relative min of -1 where x is equal to 0. And why is that? Because f prime does what? Changes from negative to positive.
Nice.
And then, well, you worked on it, great. Here, thank you. You have it right here, thanks. Beautiful, right. Yeah. Man, looks good. Welcome to room 15, calculus class, where learning comes first. Miss Aragon. This is fourth. This is fourth. No, I do not. No, she was really, she's a remote, I think, isn't she? Oh, she came back? Well, she came back, I don't think she was in pre-calculus. I have to check my roll today. But if she is back and she is in pre-calculus, it would be next period. I didn't know she was going to, because I have her in financial math remote. Sure, bye. Got to check my roll. I may have another pre-calculus student, 5th period. Okay, and then I didn't put the justification here, but this one here doesn't ask for it, does it? Because f prime is greater than 0. Okay? And then we have, for what values of x is the graph of f concave up? Well, we're going to have to take a second derivative, right? And how would we find that? Now in this instance, we have a little bit of complication, because to me the second derivative is going to be harder than the first one, or more complicated.
Oh, sneaky product.
Because here you have 6x and 6, right? Mm-hmm. And then you have this one here, x squared minus 1 squared. And over here you have the first derivative of this is going to be, that's going to be x squared, well, 2 first, right? X squared minus 1, that's the first power, times 2x, the derivative of the inside. So you get 4x times x squared minus 1. So that's going to be, I'm just going to write this over here. So f double prime is equal to those two multiplied together, which is going to be 24, is that 24x squared?
Yes.
Times this x squared minus 1, and then plus these two multiplied together, 6 times x squared minus 1 squared.
I see.
And so you have your common factors here. It looks like 6 is one of them, right?
Yes.
So 6, and then it looks like this to the first power, right? Because this is a common factor here. And then what times this equals this thing here? Well, 4, right?
Uh-huh.
So 4x squared. And then that's going to be it, right? Because if we multiply these together, we get this. Is that right? And the next one here, plus, well, that's going to be, is that going to be,
That'd just be plus
plus
x squared minus 1.
x squared minus 1. So that's it, right?
Yeah.
And then you simplify this in here all you can. And to me, that looks like 5x squared minus 1, doesn't it?
Oh, yeah, that's sneaky.
So what we have is 6, and here we have x squared minus 1, and here we have 5x squared minus 1. And so now, you take your critical numbers out of this, what are you going to have for that? Well, you're going to have,
1, 1.
you're going to have x equals negative 1 and 1. X equals 1. And then if we set this equal to 0, if we put 5x squared minus 1, so we have 5x squared minus 1 is equal to 0, add 1, we have 5x squared equals 1, and so x is going to, so we go ahead and divide by 5, right? So x is going to be equal to what? Plus or minus square root of 1/5. Or you can say 1 over square root of 5. Does that make sense? So we're dealing with, now we're dealing with this thing here. We have our critical numbers here. We have negative 1 and 1. And in between, we have negative, I'll say negative 1 over square root of 5. And here we have positive 1 over square root of 5.
Wow.
All right. And if we take f double prime over f, what do we have? What is it to the left of, basically what we have is this. We have x minus 1, x plus 1. We have factor, we have, that's going to be square root of 5 x minus 1. So square root of 5 x minus 1, square root of 5 x plus 1. So all these different things, what's the multiplicity of each of these zeros?
1.
1, multiplicity. So the signs are going to change,
Oh, they're gonna go.
just going to so really it's important, it's most important to get the first one right,
Or the easiest one, we can just plug in 0.
or the easiest one, yeah, 0. So what's the easiest one if we plug in 0?
That'd be what?
Negative times positive times negative times positive, that's positive, right? So we're going to look like this, and then the signs are going to switch on either side. So this is going to be that's going to be that, and that on the outside, we're going to have this, right?
What a genius idea by me.
Wow.
And so now we have what we need to put all this together. And what I like to do is stack one right underneath the other,
Well,
or on top of the other.
You didn't answer the question, Mr. Dede.
And so we stack these together. The negative one is going to go here, and the positive one is going to go here. And it's going to go like this, and 0 goes here too, right? 0 goes here, this, and then this and this. And then we just look at all these intervals here, and where do we start? We can start right at the y-intercept. If we plug in 0, what do we get? Well, -1, right? So 0, -1, we can just go ahead and sketch this graph here. So 0, -1, we know we're starting right there, and we can go to the right or to the left. If we go to the right, what do we have? We have, actually this is going to be minus, minus, plus, plus, and I got the order reversed, right? So we have plus, so in this little interval, all the way up to here, what I like to do is even one more thing. I like to put this right underneath this, like, see that? So we can see exactly where it is. And so just in this interval between the first derivative positive and second derivative positive, what's that going to look like? What's positive positive look like? Looks like this, right?
Yeah.
So this is going to be up to this 1 over square root of 5, and what happens between here and here? Positive and concave down up to 1, and what happens at 1? Positive, positive, like this. And then on the other side, what we have is we go from, we have positive, negative, or the negative over positive, so we are decreasing but concave up all the way to -1 over square root of 5. And then between -1, what do we have here? We have minus, minus, right? So minus, minus like this. And finally, we have this. So that's what it's going to look like. Now what I want to do, we're really out of time, is I'm going to keep it here, and we're going to start tomorrow by just looking at our calculator and seeing if that matches what we have here. It should. Okay, thank you. And what I want to do too